Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you titled F-Test, Relevance and Applications under the paper Tourism and Hospitality Research. Dear friends, after the completion of this module, you will be able to, first of all, understand F-test and its pertinence. Secondly, know the conditions or the circumstances under which this test can be applied. Number 3, the precautions that needs to be taken care of while applying the tests. Before beginning, I would like to give you a brief introduction about the topic. The present module deals with one of the very important types of statistical tests, that is the F-test and its comparison with T and Z tests. These tests have been able to capture great attention due to its highly pertinency or the applicability in different types of research study. The unit gives you a comprehensive understanding into the tests and put before you its different aspects. So friends, we'll start with the F-test. F-test is a statistical test that helps to determine in case two populations having normal distribution have the same variance or standard deviation. It is important constituent of analysis of variance. In case the population is not normal, F-test may not be used and alternate tests like Bartlett's test might have to be used. In general, the comparison of variance is done by comparing the ratio of two variances in case they are equal. Hence, the ratio of variance is equal. This fact proves its effectiveness at the time of doing the hypothesis testing for both of the sample means as well as of the regression coefficients. In order to carry out the F-test, one needs to do at the first determine the level of significance and then find out the degrees of freedom for both the numerator and the denominator so as to determine the critical values. The null hypothesis in this case is HO and an appropriate alternate hypothesis is to be used. Also, the degrees of freedom are n-1 and m-1. Then, this value is compared to the tabulated value of F statistics to know about the confidence interval and degrees of freedom. For example, let us take two methods of measuring a particular matter in water and assume that we want to find out if one is more precise than the other. Precision here is measured by the fact that a more precise method shall have a lower standard deviation and hence a lower variance. Regrettably, when one comes across some more complicated hypothesis, this test no longer proves its workability or holds importance. However, the hypotheses that involve usage of multiple regression coefficients need a different test statistics and a null distribution. Therefore, the test is named as test statistics FO and its null distribution is referred to as the F distribution. Now friends, we come to the need and relevance of F-test. F-tests were named as F after Sir Ronald Fisher. F-test can be described as the ratio between the squares of two standard deviations. These are considered as an important statistical measurement tools to know how far the data values are being deviated from the mean values. Higher the values, greater is the dispersion or deviation seen among the data values. Variance is basically defined as the square of standard deviation. Standard deviation, we all know, is a statistical tool which is easier to be computed than variances because they exist in the same units as the data values. However, the analysts make use of the variances in their computations. F-tests can be utilized under different situations, not being considered just as the ratio of the variances. Therefore, the F-test can help us to appraise the equality among the variances. This is an important part of analysis of variance, which is generally called as ANOVA. In case the population is not normally distributed, F-test may not be used. Instead, alternate tests like Bartlett's test may be used in that place. Generally, the comparison of variance is done by comparing the ratio between the two variances. If ratio equality is noticed or arrived at, in this case, the ratio of variance is said to be equal. While carrying out an F-test, the level of significance is determined as well as the degree of freedom is found to determine the critical values. The null hypothesis in this case is HO and an appropriate alternate hypothesis is to be used. Also, the degrees of freedom are n-1 and m-1. Then as said earlier also, it is compared to the tabulated value of F statistics for the required confidence interval and degree of freedom. The next topic that we are going to take on is the assumptions of F-test. Regardless of what type of F-test is being used, an assumption needs to be really taken care of. The samples which have been drawn must belong to the populations which have been normally distributed. While making the use of F-test for testing the equality among the variances, an assumption that needs to be set is that the two sample variance whose value is bigger must be placed in the numerator of the test statistics. The F-test used in case of small samples test and preferably be used if the sample size is less than 30. In order to be able to take appropriate decisions, first of all, there is a need to frame the null hypothesis as against what is known as the alternate hypothesis. The calculated value of the F-test with its associated p-value, that is the significance level, is used to decide whether to accept or reject a null hypothesis. Let's see the applicability of the test. It is used to test the equality among the population variance. This test is used to test if there exists any kind of equality among the two population variances. Secondly, this test is used for testing equality among the means. This test is carried out with the help of technique that is called as analysis of variance, or in short ANOVA, for testing the equality among the means. Thirdly, it is used for testing the importance of atavism model. Here, F-test is used to test the significance of atavism model. Further, the F-test is used to test for equality of two variances as well. Now, one of the major purposes of F-test is to test if the variances from the two populations are equal. An F-test as per the Snedeker and Cochran in 1983 is used to test if the variances between the two populations are equal or not. This test can be either a two-tailed test or a one-tailed test. The two-tailed tests are helpful against the alternative that the variances are not equal. The one-tailed version only tests in one direction, that is the variance from the first population is either greater than or less than, but not both from the second population variance. The choice is type of the usage of the test is determined by the problem. For example, while testing about any new process, one may only be interested in knowing if the new process is less variable than the old process. Now friends, we take on the test of joint significance. If one wants to test the null hypothesis to know whether the slope represents 0, it is often written more compressed form and is illustrated as null hypothesis, that is B1 is equal to B2 is equal to B3 is equal to 0. This results to the formation of alternate hypothesis. This is a test of the null hypothesis to test if the independent variables have a prognostic value or the power. On the other hand, the null hypothesis such as B1 is equal to B3 is equal to 0 can be framed to see if either x1 or x3 has such known power when regulating the values of x2. For instance, if one wishes to determine how economic policy is framed by the government of any country affects its economic growth, one may encompass in itself several policy instruments like stagflation, deflation, etc. to see if all these variables are jointly significant in the determination of this or any of the variable is most dominating. Also, introduction of dummy variable helps in arriving at some meaningful results. Dummy variables for each religion is illustrated as follows. Here you can see in this table the 4 religions have been taken, the Catholic, Hindu, Muslim and Sikh, and you can see the number who has voted. So, this is an example of a dummy table. In order to evaluate the rate at which each group votes, one can frame a regression equation with each dummy variable, where the coefficients will be framed with reference to the omitted category, which may not lead to appropriate conclusions. One can arrive at better conclusions if we test if there is any difference between the groups with the help of a null hypothesis, which is framed as all of the religion coefficients are equal to 0. It is important to take the note that we could replace 0 with any other number in our null hypothesis. Our theories often are not definite enough to test some other statement to be thought of as the null hypothesis, but it does arise. The next is the tests of linear restrictions. The joint significant tests as discussed earlier are important with regard to F-test, but fails to explain the extent of F-test fully. Hence, the test of linear restrictions are used. For example, if one wants to know whether the variable coefficients are significantly different from one another, then the null hypothesis would be HO B2 minus B1 is equal to 0. It is a well established fact, since the scale of the independent variable affects the size of the coefficient. It is important to consider that independent variables for these coefficients should too be developed on the same scale. It is possible to have even more complicated linear restrictions, such as HO B3-7 is equal to 3x B2 and 3x B2 is equal to B1-B4. Usually, in a compact manner, it is written as HO B3-7 is equal to 3x B2 is equal to B1-B4. These types of restrictions are not very common, since our theories rarely produce such harsh predictions about our coefficients. Restrictions of these kinds are useful if the coefficients need to be rescaled in order to make them more comparable. Now, calculating the F statistics. After being well known to the fact that what kind of hypothesis that can be put to test with the help of F-test, the calculation of the test statistics is required to be known to test the distribution under the null hypothesis. Now, the FO for the joint significant test. It can be calculated if the null hypothesis is of the form, that is B1 is equal to B2 till Bk, which is equal to 0. Now, after understanding the F test, it is now time to compare it with the Z. Pause. After knowing fully the F test, it is now time to compare this test with the T and the Z test. This part of the module will now present before you how F test is different from the T and Z test. It is divided into two parts. First, we will differentiate the F test with the T test. T and F test are completely two different things. This difference can be understood with the help of following points. First, T test is used to estimate the population parameter, that is the population mean, and is also used for hypothesis testing for population mean, though it can only be used when we do not have any idea about the population standard deviation. But if we have an idea about the population standard deviation, in such a case Z test would be used. For example, suppose a data suggests that the average height of boys between 10 to 15 years in city X is 5 feet. Then we want to test this hypothesis whether the height of boys between 10 to 16 years in the city X is less than, more than or equal to 5 feet. For doing so, a sample is taken and find out the height of boys between this age group, the calculation of standard deviation, and then calculate the T statistics. Once we calculate the T statistics, we will compare it with the critical value. Suppose we take alpha, that is 0.05, as it is two-tailed test, alpha by 2, that will become 0.025. We then look at the tabulated value for T with degrees of freedom, that is n minus 1 will be equal to 2000 minus 1, and alpha by 2 will be 0.25, which is plus minus 1.96. Now, once we get the T value, we will compare whether our T statistics is greater than plus 1.96 or less than minus 1.96. If the value is greater than plus 1.96 or less than minus 1.96, the null hypothesis stands rejected, meaning that the average height of boys in the city X is not equal to 5 feet. In our test statistics, if the value comes out between the plus minus 1.96, we fail to reject the null hypothesis, which means that the average height of boys in city X is equal to 5 feet. This is how one actually conducts the hypothesis testing. Second, we can also use T statistics to estimate the population mean. For example, suppose a large conglomerate like TCS, it is one of the Indian IT companies, which has employees more than 3 lakh. So, the TCS wants to estimate average over time an employee works for the company in a week. So, it might not be possible to get the required data. It's a hypothetical situation, though these days it might be possible now. Therefore, the company takes a sample, say 3000, and finds the number of extra hours of work employees have done in a week. With the help of the sample mean and standard deviation of the sample for the entire population, one can estimate the range of average number of extra hours of work done by the employees in a given week. Now, how we calculate the confidence interval to find the range is through the formula as shown on your screen. Third, the T statistics is also used for finding out the difference in two population means with the help of sample means. For example, suppose if we want to understand the buying behavior of customers from two cities for a particular product, we want to understand whether there is any difference in buying behavior in these cities or are they similar. Now, in the next step, you will be able to understand the difference between the three tests F, T and the Z. Hanji. So, first point, Z test, it is used for testing the mean of population in comparison to a standard or comparing the means of two populations with large sample, that is where n is equal to 30, whether one knows about the standard deviation or not, whereas T was, it was in the case of small sample. It is also used for testing the proportion of some characteristics in the comparison to a standard proportion or comparing the proportions of two populations. For example, comparison of the average lecturer salary of men versus women. Secondly, these two tests used for testing the mean of one population against a standard or comparing the means of two populations when one does not know the population's standard deviation and the sample size is small. If it is T test and if it is Z, the sample size more than 30. For example, for measuring the average diameter of the belts from a certain machine when having a sample size less than 30 in case of T, more than 30 in case of Z test. But if one knows about the population's standard deviation, Z test must be used. And F test helps to compare the ratio between the two population variances. For example, comparing the variability of roller diameters from two machines. Fourthly, matched pair test is used to compare the means before and after some activity is being performed with the samples. A T test is mostly used when the sample size is small, whereas a T test is used when the sample size of the population is large, that is more than 30. For example, the average weight of subjects before and after following a diet for 6 weeks. Now, the F statistics. Z or T statistics is used to estimate the population parameters, that is the population mean and the proportion. It is also used for testing the hypothesis for population mean or population proportion. Unlike the Z statistics or the T statistics, where we deal with the mean and proportion, chi-square or F test is used for finding out whether there is any variance within the sample. F test is the ratio of variance of two samples. For example, suppose in a manufacturing plant there are two machines producing same products and the management wants to understand whether there is any variability among the products produced by these two machines. Here the researcher will take samples from both the machines and then find out the variability and test it against the null hypothesis, that is the prescribed limit. F test also forms the basis for the ANOVA. So friends, let's now summarize the module. Friends, there are various kinds of statistical tests that can be applied on the data to test their significance level. Out of all these tests, one of the most important tests, that is the F test, has been discussed here. This test has been able to capture great attention due to its high pertinency or the applicability in different types of research studies. This unit gives a comprehensive understanding into the F test. The test of joint significance has been discussed above, to the test of the null hypothesis, to test if the independent variables have a prognosticative value or the power. On the other hand, the null hypothesis such as HO, where V1 is equal to B3 is equal to 0, can be framed to see if either x1 or x3 has such known power when regulating the values of x2. Along with the introduction about the F test, its need and relevance along with the test of linear restrictions as well as the test of joint significance have been explained, highlighting their counter importance in success of the proper application of the F-test. The different purposes for which F-test can be used in research are also discussed, that is, its applicability that can be proved has been also significantly highlighted for the research purposes. In the end, the difference between F-test and the T-test along with the Z-test have been clearly explained, highlighting their suitability and relevance at various times depending on their need. Thank you.